is to define a non-commutative skew field. Okay, so what is the game plan? So first I will introduce 4 symbols. Okay, one is the symbol 1, I, J, K. Okay, and these are 4. Let us, okay, I will exclude this one. Okay, 3 symbols, and which are related through the following relations, which are related through the following rules. Okay, what are those? Now if you put I and J, just placing I and J, this will be K. Okay, there is a third symbol. But if you take the reverse one, that is Ji, then that should be minus K. You just put a minus here. Okay, and in a similar way you can just continue the cyclic order. That is, if you put JK, it will give you I, and the same way you can write minus KJ, and then KI equals to J, that will be equal to minus IK. And if you write them together, IJK, this will give you minus 1. Okay, and another set of relations are, if you put I and I together, that will be denoted by I square, it will be minus 1. In a similar way you can define J square, K square. So these are all minus 1. Okay, okay, and the last one is that if you take any real number, suppose you take for all A belongs to R, okay, then AI must be equal to IA, AJ must be equal to J, AK must be equal to K. If you take any real number and if you put the real number A and then I, then it will be equal to IA, AJ J, AK K. Okay, and with respect to these relations, now we shall define a set of objects. The objects that are looking like this one: AI, A plus BI plus CJ plus DK, where this A, B, C and D are real numbers. Okay, we consider the set of objects which looks like this expression. Okay, now what to do with this set? Now we shall define. So our aim is to produce an example which is going to be a ring which will be non-commutative, but the ring will have an identity, multiplicative identity, that is unity, and every non-zero element of that ring should have multiplicative inverses. Okay, so the only thing that it will lose the commutativity. Commutativity ছাড়া বাকি সবটাই এর আছে, শুধু commutativity-টা নেই। তো এরকম একটা রিং আমরা ডিফাইন করছি। ওকে, so what is the definition of its addition? How to add these two objects? Addition is very simple as that, by taking two objects, a plus bi plus cj plus dk and a dash plus b dash I plus c dash j plus d dash k, and if you add, then what would be the definition? You just add component wise. That means the first is a, here a dash, so you add a plus a dash, and then you take b plus b dash, I, c plus c dash j, and then d plus d dash k. Okay, so this is very simple. This is very usual sense of addition. Okay, now what about the multiplication? So to make the definition of multiplication, you can follow an easy algorithm. That is, you just multiply these two expressions component wise. Okay, that means, by term wise, not component wise, sorry. So that means just a dashed, a b dashed I, a c dash j, a d dash k. Okay, then again come back to this one bi, so it is bi a dashed. Now you have already assumed that for any real number ai equal to ia, right? So you can use this one. So that means bi a dashed, so that will be a dash b, right? A dash bi. Secondly, bi b dash I, bi b dash I, that means b b dashed, sorry, I should write it as, okay, okay, this b a dash. Okay, now it will be b b dashed, and then it is I square, so that means it is minus 1, right? I square is minus 1. So you just using these relations, and you can just multiply the two expression term wise, and with the help of these relations you will get another object of this form, and which will be, suppose that it is capital A plus bi plus cj plus dk. You can calculate this a b c d with respect to this relations. Okay, এটা করে দেখো, ঠিক আছে? মাল্টিপ্লিকেশনটা কি দাঁড়াচ্ছে, একটু বড় হবে, আমি আর লিখছি না ওই জন্য, ঠিক আছে? এই ফর্মেই হবে। এই ফর্মটা আসবে কি হবে, যেমন ধরো সাপোজ ইউ টেক this bi c dash j, so that will be b c dash ij. Okay, for example b I dot c dash j, so that will be b c dash ij, but ij is k, so therefore it is b c dash k. Okay, তাহলে এইভাবে তুমি মাল্টিপ্লিকেশনটাকে ডিফাইন করতে পারো উইথ দি হেল্প অফ these relations.
ঠিক আছে স্যার।
ঠিক আছে, and you can so left as an exercise to check that h plus dot forms a ring. H plus dot forms a ring. Okay, Okay, so this H plus dot forms a ring, and not only that, it will be a ring with unity. What is a unity? Unity will be 1, right? 1, the real number 1. Okay, because 1 can be written as 1 plus 0i 0j 0k. And for any object of this form, if you multiply any object from H with 1, then this will produce the same object, right? So therefore this is the unity of this ring. Okay, now whenever you have the multiplicative identity, then it is your natural inclination to check that whether every non-zero element will have multiplicative inverses. So let us let x belongs to H, where x is a plus bi plus cj plus dk. Okay, now with respect to this H, you can define again as you have done in the complex numbers. You can define the conjugate of x, and the definition is a minus bi minus cj minus dk. Okay, and also you can define the norm as we have defined modulus of complex numbers. You can define this is the norm of small x, but sometimes it is called, you can call it length of x. Okay, and it will be defined as what are the components of x? A, B, C, D. So you can define this as a square plus b square plus c square plus d square. As you have defined modulus of complex numbers, that is, it will be the root over of real part square and plus complex part square, right? So therefore now we will multiply x with x bar, then you can check that this will be a square plus b square plus c square plus d square. So for this one you need to first write down this multiplication. Okay, and then you can check that x dot x bar will be a square plus b square plus c square plus d square, and so it is norm x square, right? Similarly, x bar dot x will be the same. So therefore for non-zero x belongs to H, so x dot x bar by norm x square, x bar by norm x square dot x is 1. So this defines the multiplicative inverse of x, that is x inverse is x bar by norm x square for all non-zero x. So therefore, so this shows that H forms a skew field, right? But here you will lose the commutativity because you can easily see that this one, particularly this one, that ij is not equal to ji, it is minus ji. So by the preliminary definitions, it follows that this H is not, which is not commutative, right? Okay, so these objects in H are called quaternions, and H is called the ring of quaternions, which is an example of a non-commutative skew field. Okay, that is, so this is an example of a skew field without having commutativity. That is an example of a skew field which is not a field. Okay, and this is very interesting to be noted that such examples are very rare. Okay, so non-commutative rings are very rare. Okay, sometimes this is called the ring of Hamiltonians. Okay, because due to the name of the mathematician Hamiltonian. Okay, Hamilton, sorry. Okay, so this is an example of a skew field which is not a field. Okay.